Topic of this presentation is in-source fragmentation searches in NIST26 Chromatogram window. It includes both a video and an associated handout. Often, certain topics are not discussed in the video that are shown in the handout, so check out the handout also. This is on my website, but it's part of a full course on NIST26 with the newly integrated deconvolution and library searching for EI, GCMS, and LCMS data. In source, MSMS are spectra when a fragmentation occurs in the source. So when you run it down an LC column or you infuse it into the instrument, you'll see the mixed precursor plus the fragment ion. You usually see the protonated molecule or maybe the sodiated, but alongside you'll see multiple fragment ions produced before any collision cell. That's the key difference between true MSMS and MSMS isolated precursor goes to a clean fragment ion. In source, everything fragments together. You get a mixed spectrum. There's some other names that in source ions are referred to below. So for example, if NIST saw these ions below when infusing a reference standard to get their reference spectra for their library, they would obtain MS2 spectra for all the molecular ion atoms and the fragment ions. Of course, in their case, it would be at high resolution. So they would take the 377, do an MSMS at it, the sodium also, but they'd also take these fragment ions that they observed in the MS1 and take them to MS2, plotting them to give their MS spectra. There are certain molecules that primarily lose water from their M plus H in positive ion electrospray. For certain classes such as cholesterol, there would be no MS2 spectrum in the library if the M plus H ion was necessary. There's essentially no significant ion intensity as noted for M plus H ion addicts for cholesterol in many instruments. Thus, the major MSMS spectra is for the M plus H minus water peak at 369.3506 in the NIST MSMS library. You can see the MSMS spectrum shown below of this 369 ion showing the ions of interest in the MS2 spectrum. Thus, for such molecules as cholesterol, the chromatogram window search results are shown for M plus H minus water with the correct structure. This is only done for small losses such as ammonia, water, and even for sodium addicts. Another example is shown for another compound that only shows an M plus H minus water to show its MS2 spectrum. And in case of that, if it was one of your identities in your list, it would show up with the correct structure within the chromatogram window. So we've discussed the first few topics here, and I want to show you how to get these in-source spectra and get the correct structure. So the most important thing to see the proposed structure or structures, one must send the spectrum of in-source ions to the NIST LibSearch window. And I'll show you how to do that within the software. So I brought up a file here that has some in-source ions in it. So to find an in-source ion, you have to use this unfiltered score. So it has not filtered out these in-source ions to calculate the score. If you want to see those, it's best to go up to the highlight the score, and let's say pick all ions above 800 in our in-source. If we go and right click on here and go to properties, you'll see what all the different little circles mean. The green's always selected, highlighted is this yellowish color. In source will be blue, hybrids will be green. So now we'll have all of our in source labeled in blue. So the other easy way to look for them is to sort by unfiltered score. And go to the top of the list and start looking for things where the score is much, much lower than the unfiltered score. So look at this one here with the unfiltered score of 928. The score is of 22. So what will be shown for the structure will be the score for the 22, which is not very useful in this case. So to get the proper structure, you have to right click on it and say library search. And what it's doing, it's sent that spectrum to the LibSearch window to get the possibilities. You have to make sure this is set up correctly for this. So we'll go to the library search options, look at our search. We're doing an identity MSMS, which is good. That's the proper thing. So that's good. MS-MS, precursor 20 and 40. Those are good parameters. Libraries, this one's doing APCI and the high resolution. That's okay. You can do also the low resolution or your own libraries if you wanted to. And so all that's set up properly there. So you can say, okay, and you could save that as your configuration, part of your configuration if you wanted to for your in-source ions. But so what we have at the bottom now is the best hit for the in-source. And now you see it's 928 as we saw within the chromatogram window, but now the correct structure or a correct structure that's a possibility is shown at the bottom. So at the top is our unknown in-source ion at 247. At the bottom, you can see the MS2 best hit. And if you go over and look at the text for this, you'll see it is an in-source ion. Is the precursor type is M plus H minus C2H7NO. So that's what the compound lost to give the precursor ion, and then that precursor in-source ion was fragmented to give the MS2 spectrum observed at the top. So this is pretty much how you identify these in-source ions. If you go back to the chromatogram, let's right-click and go to Properties and bring it to log scale, make it a little easier to see some of these blue ions. Now you can see them. The green one's the one we have selected, so we need to get off of it so we can tell what color it is. So you can see that ion that I selected to send with the 928 and 22 was labeled blue. And here's some other in-source ion. Here's 1, 2, 3. So there's a bunch of them in here, and you could send those to the lib search to get structures. But the key thing is when you send them, look for things that the unfiltered score is very high and the score is very low. Those are the ones that'll be useful to actually get MS-MS data. So a lot of times the MS in source will be the same as the score, and the score will be the correct one. Here's one that might be 737 for the unfiltered, which would be an in-source ion, and 0 for the score. So definitely the right structure here is not correct. You need to send it to the lib search to find out the identity of your unknowns. It was shown as an in-source ion here. So that's how you go about identifying those in-source ions, ones that NIST has added to the library. They're a characteristic of MS1 spectra of the compound of interest. I hope you have found this demonstration useful for the identification of in-source ions in your work. Good day.